Hello. Today we're looking at notes for 3.3, properties of logs. We're going to kind of revisit and use some of the properties we talked about last time. Remember, you have this help sheet, and the properties, the basic properties we talked about are this section right here. So today we're going to talk about properties that allow us to expand and condense logs. We talked about this first one last time called the change of base. And the change of base allows us to take something that's not in base 10 or base E and work with it. So for instance, if we were using our calculator, then we would have used, for anything base 10, we would use this LOG button, and for anything base E, we would use the LN button. So when we're doing something here, if we want base 10, we would do log. Remember, there's no subscript for base 10. We could do 5. And that's going to give us our value, or maybe we're dealing with a natural log. So we could do the natural log button, which is base E of 5, and it would give us that. The problem is if it's not base 10 or base E, we can't use those buttons on the calculator, so we have what's called the change of base formula. And so what that might look like is, let's say I have log base 7 of 5. Then in order to do that on the calculator, I would have to take log base 7 divided by log base 5. And so you would write it out like that. You could do that in your graphing windows or your home screen windows, and it would calculate that for you. And so what it did is it took it out of a base 5 and put it in, or base 5 and put it in log base 10 so I could use my calculator. But now with our new operating system, we have a template that we can use. And so we press alpha window, and it's choice 5 where it says log base. And so when you do that, it actually gives you a template where you can plug it in directly. So you can say log base 5 down here of 7. And when you execute it, it's actually going to do this calculation, but it's going to spit out the answer so you can see the answers are the same. So that's finding the change of base. On the calculator, you would do Windows Alpha, then 5. Okay? So it's always important to know what your calculator is doing so you know it's not just math magic. So there's that. We're going to look at properties to expand, which means take it from a single base log and expand it out to multiple statements that have the word log in it. And we do that when there's a product in the argument, whether it's natural log or log. We can expand it with addition, which you learned last year. And we also learned last year that if there's a quotient in the argument, you can expand it with subtraction. If there's a power in the argument, then you can drop the power to the front and make it a multiplier, and then you have the power times the log. And that works true with natural log or LOG log. So properties can be used to condense or expand, and you should use those properties. It makes the math easier. It lets you oftentimes simplify without needing a calculator. Once a problem is condensed and put in the condensed form, then you need to, once you have those multiple terms, then you can use some of those log rules that we talked about last time, and also the exponent rules. So the problems that we're going to work through are these. We're going to evaluate, we're going to write in using a specific form of a log. We're going to expand, taking this argument and expanding it out, and we're going to take an expanded form and condense it back down. Okay, so the first one is to evaluate. So let's practice on our calculator here as well. So that means if we did the change of base, we would say log of the argument divided by log of the base. The base is in the bottom of the fraction. Or we can use our new template where we do alpha window, pick number 5, we can put in a 4, we can put in a 25. And so that's going to give us our value. So remember, we could still do it log of 25 divided by log of, what's the base there, 4, and we get the same thing. Sometimes people, even though they have this option, will still do this if you're just wanting to do a quick calculation. It's easy to type in, but you do have options there. So we got approximately 2.321. Remember, the standard decimal for advanced classes is 3 decimal places. So you're always rounding to 3 decimal places unless it tells you otherwise. So then we're doing log base 7 of 3. Feel free to stop the video at any point if you want to do it before you see the answer. That's the joy of getting to watch the video. So we're going to put it in our calculator. We're going to use that template, And hopefully we will get that. Yes? Great. All right. So the next part we're going to look at in this problem is we're going to take this natural log statement and we are going to rewrite it in terms of natural log 2 and natural log 3. And so the first thing I would notice is it's got a quotient in the argument, so I want to expand it with subtraction, and then I want to look at each term. So when I expand it with subtraction, I have natural log of 2 minus natural log of 27. 2 is already in base 2, so I'm good there, but 27 is not. So I have to think about how can I rewrite 27 using a different base, and specifically a base of 3. Well, we should all know that that's 3 cubed. And then once we rewrite that argument, we now see it has a power, so the power drops in front and becomes the multiplier. And then we have the power rule there. Okay, the next one, we have a third root of 5. So to expand this without the calculator, we're going to take our radicals and change them to rational exponents. So we get base 5 to the 1/3. Then we can drop the 1/3 in front. And so we have this. So remember from last time when we had the log of the base and the log of the argument. So I would think 5 to what power gives me 5, and that would have to be 1. Or now I can think today, change of base. Log of 5 divided by log of 5. Anything divided by itself is 1. Multiplying that by 1/3, not 3. I just caught a mistake and fixed it right there for you. So then I end up with 1/3. All right, so let's move on to 2C. So again, I have a product in my argument, so I'm going to expand each one with addition. Then I can see that I have powers, so I'm going to drop the powers to each term. So when I expand it out, I get natural log x squared plus natural log y cubed plus natural log z to the 4th. Then I'm going to drop all 3 of those powers down in front of the log, and I get this, and that's my final answer. Okay, so take care of your powers last, but don't forget to take care of your powers. All right, D. So D, I have a quotient in my argument. So here's my quotient. I'm going to change that to a rational exponent. I'm going to expand this with subtraction. But once I get the fraction expanded, notice I have a product in the numerator. So the product needs to be expanded with addition. So I've got all kinds of stuff going on in this problem. So here's me rewriting it with rational exponents. And then I did the top minus the bottom. And notice there's the word log in each term when we expand it. And then I need to expand this with multiplication. So that's natural log of x to the 1/2 plus natural log of 3. And then I need to drop my powers that I have throughout the problem. So my final answer is going to look like that. 1/2 natural log of x plus 3 natural log of y minus 5 natural log of z. Logarithms and exponents are a big part in calculus, so it's really important that you're getting these rules and understanding how to handle them and separate them into smaller pieces. The last set of problems are condensing. So this means now I have them all out in the multiple pieces, and I want to bring that back down to a single log term. So the first thing I want to do when I'm taking care of this is I want to bump all these powers back up where they belong, so they're back in the argument with the base that they originally started from. So I get log x cubed, log y to the 4th, log z squared. Once I have all of the powers back, then I look at my operations left to right, and I can see here is addition, so I know these were connected back together with multiplication. And then once I have this, it's going to connect back together with this by the subtraction sign, which means division. So putting these first two together, I get log of x cubed y to the 4th minus log of z squared. I haven't done anything with this back piece. And now I have this minus this, so the arguments are connected back together through division. And that's what my problem looks like. So one word log now after I condense back. So you can see how we started with each statement having its own log in it to condensing it back down to where there's one word log for the entire argument. So keep in mind when you're doing this, I always start by talking through what I see, just like I do in class. It's a good skill to have, kind of gives you a plan before you start the problem. So when I'm looking at this, I see that I've got an argument here with some multiplication in it. I see that I have a number in front, so I had a power. This power goes to the entire argument when you bump it back up. So when I bump that back up, it's 1/4 to the whole argument of 25x. All right? So a final answer could be this, or it could be this if you take it back to the fourth root. It just depends on, how the problem is, but both of these are exactly the same thing. So things to remember, it's not the fourth root of everything with the log in it. That would be incorrect because that power goes to the argument, not the word log. And so if you're doing that to power, be sure that you don't accidentally do this and try and take the whole thing to the power of 1/4 because it's just the 25x. So just something to watch out for there. All right, on problem 3C, so what I see when I look at the problem is I have the same base, it's base 2. I have some multipliers out in front of my logs, and I have some argument. Now notice the argument has plus in it. That is not something we can expand with our expansion rules, because to expand with your expansion rules, this needs to be a product or a quotient. Addition and sum are not products or quotients, so be careful there. I always see students try to do that. So let's bump all those powers back up. So we're going to put them back up where they belong using that power rule. So notice it's the fourth is just to this argument, and the third is just to this argument, not to the log itself. Now that we have the powers up, we can see it's connected by a minus sign. So that means the arguments get put back together with division. So I have one word log base 2, and then I have this argument divided by this argument. So all of this becomes the argument as a division problem with a single log base 2 in the beginning. Okay, so when I look at 3D, I can see that I have a multiplier here, so I'm going to have to apply the power rule first. I can see that this is plus inside, so there's no expansion there. I can see the two natural logs are connected by a minus sign, which means I'm going to have to divide their arguments. So the first thing I would do would be get that power back up where it belongs, and notice the power goes to that quantity, x plus 4. And then the subtraction means I'm going to connect these two back together with division. So I take this argument divided by this argument with one word log out here. And this time it's natural log instead of log log, which could be any base. And finally 3e. So this one looks kind of daunting when you look at it, but we're going to take it in pieces just like we've been doing. I'm going to save this 1/4 to the end because it's 1/4 of everything in here. So let's clean all this up first. So I can see when I initially look, I've got a multiplier here, so I know I'm going to have a power. I've got a subtraction here, so I know these arguments are going to connect back together with division. And then I have another one here. So that means I've got a fraction within a fraction, so I'm going to have to watch out for that. So the first thing I'm going to do is bump that 3 back up and get it back to where it belongs. And then I'm going to start left to right on the inside, and I'm going to use this connection. Remember, they're connected by a minus, so that's division. And then I have another connection with a minus, so these two arguments are going to get divided. And so we end up with a complex fraction inside. So if you think about this, remember we can always take the numerator and pull it off, and that would be x plus 1 cubed over x times 1 over x squared plus 1. So you're dividing by this, which means you're multiplying by the reciprocal. So then I can see how this is going to fit together and get that complex fraction out at the top, right? So when I do that, put it back together, I get this times 1 over x times this. So this is what my argument looks like. But I'm not finished because I haven't taken care of this 1/4. So remember, a multiplier goes to the argument. So the fourth goes to this right here, and only this, not the natural log. So this is what our final step is going to look like. It's this piece to the 1/4. So be very, very careful and make sure either way you go, it's 1/4 of the argument or it's the argument to the 1/4 power. Don't fall into the trap where you forget and take all of this to the 1/4 power. That's not what we're talking about. We're talking about the 1/4 is the argument or the fourth root of the argument. So in either case, that doesn't mean we can take the fourth root of the natural log or that we can raise natural log to the 1/4 power. So be very careful that you don't make this common mistake right here in your problems. So everything we did today is very rules-based, applying the rules. You have all of these expansion rules, remember, on your help sheet that's on Canvas for this section. So don't forget that if you need it. And we will see you next time when we start talking about equations. Thanks, guys. Bye.